Hello students, today we'll be doing one more problem based on work energy principle. Let's have a look on the question. Find the velocity of block A and B when block A has traveled 1.2 meter long along inclined plane. Mass of A is 10 kg and that of mass of B is 50 kg. Coefficient of friction between block A and inclined plane is 0.25. Pulleys are massless and frictionless. You have to use work energy principle and solve the problem. Now the question is given having a diagram which is in the form of a black color. Now let's have a look with the question, and then with that we can just put down the data. The mass of A is 10 kg, which is mentioned. Mass of B is 50 kg, which is mentioned here. Mu equals to 0.25, which is coefficient of friction. So it is mentioned coefficient of friction between block A and inclined plane is 0.25, which is between these two. Okay. Similarly, S is equals to 1.2 meter. The block A is traveling 1.2, means this block A is traveling 1.2 above. Now when you'll see the question, there is nowhere mentioned that the block A is moving above, but just with the help of the mass of the two blocks, mass of A and mass of B, 10 kg and 50 kg, we can assume that block B moves down as it is 50 kg. So if it is moving down, this will go above, and once it is going above, it is covering a distance of 1.2 meter. Okay. Now one more thing, if I'll draw the FBD of this, so for that, where the tension will be acting, it will be away from the body. But the same thing, if I'll do it for the pulley, the tension will be away from the body, which will be the same tension. I hope you understood. Similarly, as the pulley is frictionless, away from the pulley will be T. The same T will be away from this pulley will be taken as T. In similar way, the cord continues, the rope continues. So here away from this pulley is T, and away from this support will be this, which will be the same value. These two T will be acting here away from the block, 2T. Similarly, away from the pulley will also be 2T. I'm just not drawing it here because it is not having much space here. So away from the pulley 2T, away from the block 2T. Okay. Now just have a look that if the block A is moving upward direction, this will be coming downward direction. Means whatever motion or whatever work done is happening here will be equivalent to whatever the work done happening here. Once again repeating, whatever the work done will happen here at point A will be equivalent to the work done acting at point B or a block B, and the same thing we have mentioned it here. Now work done is force into displacement. So force here is acting like a T and displacement is XB. So B block is moving some displacement which is XB. So why come it is coming 2 here? The force here is 2T, and that's why it is 2T into XB is equals to T into XA. It will go above. T into XA. TT got cancelled. It becomes 2 times of XB is equals to XA. We'll differentiate with respect to T. It will give me a relation 2 times of velocity at B equals to velocity at A. I hope you got this relation. Now we'll just have a look with the different types of work done acting on it. So very first, work done by a gravity. So work done by gravity at B. So we are talking about this. So if it is coming down, means what, it is acting mgh. Here many students ask me the question that if the block is moving downward, then G will be positive. It is not like that. Whatever comes down will be taken as negative. So here, as it is moving down, G is always acting downward direction, hence it is taken negative. The H covered distance, the displacement which is covered, will also be minus. So together it becomes plus, which is 50 into 9.81. Now H equals to 0.6. How we got this value? Now, as we see that from here, it is covering a displacement or a distance of 1.2. So as it is 2 times here, so here it will be half of it, because 1.2 will be getting adjusted between these two ropes, and it will take it down half of it, and that's why we have mentioned here 0.6. I hope you understood. This is moving 1.2, so 1.2 will be getting equally adjusted between these two ropes, and this block will be moving down. So if 1.2 is equally adjusted between these two ropes, this block will move only 0.6, and that is 0.6 here. If we'll multiply that, we'll be getting 294.3 joule. Okay, let's move to next. Work done by gravity at A. So about this point at A, again, as this block A is moving above, so G once again negative, H is positive, the H covered distance will be positive, will be minus mgh. The mass of this block will be 10, so 10 into 9.81, which is m into g. Now talking about an H. Now if you look from position 1 to position 2, the position 1 is right now the block is. Once it will move, it will reach to position 2. That position 1 to position 2, it will cover 1.2 meter. This is 40 angle. So this side will become what? 1.2 sine 40. And we are taking that H as 1.2 sine 40. Now why we are taking this rather than 1.2? As you are knowing, the displacement is a shortest distance covered. So 1.2 sine 40. If we'll calculate that, we'll be getting minus 75.668 joule. Now we'll move further. Work done by friction. So work done by friction says that minus mu k n into s. Work done by friction is frictional force into displacement. So frictional force is minus mu k n into s. Mu k here it is 0.25. So here 0.25. N, at the place of n, we'll be writing mg cos 40. As mg is acting downward direction, it is having an angle of 40 degree, which is mentioned here, 40 degree. So 40, so it will be similar to this angle, mg cos 40. N is equivalent to mg cos 40. So here it will be writing m into g, which is 10 into 9.81 cos 40, and at the place of s, we'll be writing 1.2 distance traveled, 1.2 distance traveled. So that will give me minus 22.545 joule for the work done by friction. Now we'll apply a work energy principle. Now what does work energy principle says? Work done at 1, 2, 3 is equals to change in kinetic energy. But here there are two blocks, which is block A and block B. So we have to take the kinetic energy at both the sides. So change in kinetic energy 2 minus change in kinetic energy 1, or we can say kinetic energy 2 minus kinetic energy 1 for B, kinetic energy 2 minus kinetic energy for A. We'll place this all value 294 minus 75 minus 22.4545 will be this value. Here we'll be writing half m v2 square minus v1 square for B, half m v2 square minus v1 square for A. If we'll calculate this, we'll be getting this value, half m at the place of m, which is mass B, is 50, v2 is v2 square, we have to find out, 0, v1 is 0, as the question doesn't mention anywhere that the body is moving and then it starts the next motion. So we have considered here that velocity at the starting is 0, and that we are placing it v1 equals to 0 here. Similarly, for the second half, m is your 10 for mass of A, v2 square, this is taken as 0. Now here we have only mentioned 196.02087, half 50, half we have taken common 50, this as VB square we have mentioned, and this as in VA square we have mentioned. Now this relation, what we got it here, 2 times of VB equals to VA. If that relation, if I substitute it in this equation, then by solving it, at the place of VA, we'll be putting 2VB. So everything will be in the terms of VB, and then we can find out VB, and that value will be 2.087. Once you got VB value, that VB value will substitute it here, you'll be getting VA, that is 4.17 meter per second. With this, I hope you understood the whole problem. Thank you.